And we're on the air. Good afternoon, good morning, good evening, wherever you are in the world, friends. Welcome to Code Mentor Office Hours. My name is Mark, and today we're really excited to continue our JavaScript framework series. If you've been checking out any other office hours, we're sort of in a big focus period of hitting a lot of JavaScript topics, and we're really excited today to dig into another one. So I'm going to introduce our guest, and he's going to give us a presentation on Angular, and then we'll have a Q&A session. So this entire time, feel free to populate any questions into the group chat, or if you're in the other room, use the Q&A app. Yeah, moving forward, we're really excited today to have, oh, let me just mute someone who just joined. Keep it nice, quiet. Thanks. Gleb Bahmutov is a full-stack engineer who currently works at Kensho, a company that is empowering the largest financial institutions in the world with technology that brings transparency to markets. His prior experience includes working at UTest, bringing together and updating various front-end technology stacks, and MathWorks, bringing the power of MATLAB to the browser. Gleb spent 4 years as a researcher at Everyscape, writing panorama stitching and 3D modeling software. And before that, he worked calibrating 3D laser scanners and developing white light scanners. And even before that, he wrote distributed database access software that worked across Objective-C, C, and Java systems. Gleb is a doctorate from Purdue University, and he blogs over at glebbahmutov.com on topics relating to software craft. So everyone, please quietly welcome Gleb to Office Hours. And
Thank you.
I'll kick it over to you.
Thank you, Mark, for that introduction. Let me share my screen because I think the web browser is a lot more interesting to watch than my face. Screen share, and let me go to this one. Okay, so everyone can see kind of a bunch of slides. So my name is Gleb. I work for a company called Kensho. I blog about different stuff. In this particular presentation, I'll be talking about AngularJS performance. And this kind of grew out of the app that we're building at Kensho. App looks like this. It's a huge financial web app. And it has a bunch of widgets. This is just part of one screen. But we have charts and graphs and data table. And each table can have anywhere from a couple of items, a couple of rows, to tens of thousands or even hundreds of thousands. Same with charts. So as we were developing this application and we're trying to sell this, we hit performance issues, right? It wasn't right away. This kind of happened after maybe half a year of work on this application, but we had to solve this. And in the process, I kept writing a blog post, and that's the link to the blog post. I can copy it into the chat for people to kind of check out. Looking at a blog post, there's a lot of content because as we were hitting bottlenecks, we would solve them, and then another bottleneck would appear, and we would solve that one. So the blog post kind of grew organically over maybe half a year. I still keep updating it. Since that time when it was published, I actually moved my blog. That's why the link that pops up in Google search is not the latest blog post content. But it's pretty popular. And some of the examples of techniques that I cover in that blog post are listed here. The most basic one that I'll show today was how to profile your web app, your AngularJS web app, using code snippets. Not that many people know about code snippets, so I'll show how useful they are. And then the top bottleneck that you probably will hit in your app is not AngularJS. It probably will be somewhere in your code. And so I'll show what the V8 JavaScript engine does and how it shows the potential bottleneck. And then we'll go through a couple of extra techniques depending on the time. The most important ones is to optimize the idle digest cycle. AngularJS is really good for using plain JavaScript objects to keep your data, your scopes. But that means that it has to do a lot of work trying to determine what changed and what has to be updated on the screen, the digest cycle. So I'll show how to optimize because it runs all the time. If you don't optimize it, your application will appear very janky, very sluggish. And then the second most important technique is binding data only once but never changes. So I'll show how to do that. And then maybe if we have time, I'll show how to update only the elements that are visible on the screen and not update things that the user doesn't see. One thing I want to note before we start, there's a difference between benchmarking and profiling. So if you seen GSPerf website, there are micro benchmarks where you analyze for loop versus array for each and things like that. This is not what I really like. Instead, I like profiling the actual live application. You can spend a lot of time optimizing a function that's not really the bottleneck. And so micro benchmarks are not that useful, in my opinion, in the real world. So instead, I'll show the profiling. So we're going to take a small GitHub repo that I have as an example. Primes, you can go there, check it out. I have it open here. And all you have to do is just clone the repo. You can check out each step. Occasionally, you'll have to install maybe third-party libraries, but it shouldn't be that difficult. And then each tag in the repo shows different technique, progressively more advanced. I will start with a simple step 0, the initial application. And let me just open it really quickly. Okay, so here's my application. I enter number of primes, 100 or 10, and then I click find, and then it finds first n primes. The method to find the primes is really brute force. So it finds it fine for first 10, maybe for 100, but as soon as I hit 1,000, the browser is actually frozen right now. As you can tell, find button is frozen. I cannot enter anything else. It takes a couple seconds just to find 1,000 primes. So where's the bottleneck? So the first thing that I'll show is how to actually find the bottleneck when you run an Angular method on a scope. So let's open our DevTools, and I'm going to attach it because we have plenty of space on the screen. So typically, the first thing that I'll start doing when there's a performance problem, I will go to my Profiles tab, and I would click Start Profiling button. But even before you do that, it's important to go to the settings, and under Profiler, make sure that you have high-resolution CPU profiling turned on. That gives you a little bit more accurate performance numbers. Also, I usually disable cache. It's not important for this example, but it's important for your overall application to be fresh and not being cached. Everything else, I would keep the default settings. So I want to know why finding 1,000 primes takes a little bit too long. So I will go to Collect JavaScript CPU Profile, and I'll click Start. I'll go back to Find, and I'll click it again. And I'll just wait until the button becomes enabled again. So usually it takes about 8 seconds, I think, in this case. OK, it's done. I click Stop. Now I see the profile that's collected. And this is just the CPU. The profile is shown from the time I click the button at 0 all the way to up to 12 seconds. And the actual search takes right about here. If you select it, then it will focus on that region. So right about 8 seconds, I would say, maybe 10 seconds. Below you see almost like a pyramid. This shows the initial call, event handler. In this case, I click the button, so it calls event handler. And then probably there is Angular code, and then it calls scope apply, because every time I do ng-click, like in this case, it kicks off digest cycle, kicks off the apply. And then this evaluates something, an expression, and then it goes back almost to the find method all the way down to find prime. So this is my user code right here, my last find prime, the last row, and inside there is prime method. And I can zoom in a lot more, and I can see individual calls. All right. So I can actually see how long each is prime takes or find prime takes. Right now I'm in chart mode, so this is useful, but you can switch to heavy or bottom up. And let me zoom up because I want to make sure that everyone can see this. So this shows each function in aggregate. And the most expensive function in aggregate, that means if you sum the individual calls all together, this function takes the longest. It takes almost 5 seconds. Find prime, it takes almost 9 seconds, but it only spends less than 4 seconds inside itself. It spends 5 seconds actually calling is prime. Even these numbers are not that accurate, because if we go back to the chart, as you can see, I actually measured this code over, let me reset this, over 12 seconds. And this is a very simple application. In a real world, as I try to, for example, to click the button to record, I might actually trigger different scroll handlers, mouse over, basically starting and stopping the profiling manually is very inaccurate. I really would like to be able to profile an individual method call by itself, automatically. Luckily, we can do it using an interesting feature of Chrome browser. If you go to Sources tab, you have a couple of tabs on the left. One is index, right? This is your application. Here's my isPrime function, find prime. So this is basically my code that the page loads. The second tab shows content scripts. These are scripts loaded by Chrome extensions. And finally, there is a last tab called Snippets. Now, these are code snippets. These are pieces of code actually stored inside the Chrome browser. You can create, new snippets. You can rename. You can edit. The files stay in local storage. You reopen the browser. It's there. I will show an example. For example, the first paint. You can run it using Command Enter. And as you can see down below, it executed this code and tells me that it takes 200 milliseconds to actually open and paint this page. And these snippets can be as complicated as you want. I have a whole repo of these code snippets online. Okay, so I just got a question that is a little bit hard to decipher. Yes, let me zoom in. So this source could be anything. In our case, we really are interested in a specific scope method. So let me zoom in here, and let me show the source a little bit. So when I click the button Find, I'm executing a find method, right? I have a code snippet called profile scope method, and all you have to do is give a selector and a method name. And let me execute this code snippet. What it did, it actually wrapped a method on a scope that it accessed and added a couple of calls. So now if I click Find, notice at the bottom, it actually started profiling automatically. So instead of me clicking the button and profiling lots of idle time, this only profiles the method execution and then restores it. So I switch back to profile, and it's stored right here. Notice that now it's a lot more precise. I started the event handler, and that's all the profile shows. So right now, the event handler runs for about 9 seconds. I'll switch to the heavy bottom up. Now I don't have any extra idle time in my profile. The only information you see here is the JavaScript that runs when I click Find. Chrome runs a V8 JavaScript engine, and the V8 JavaScript engine is great, but it's not. It has a couple of performance gotchas. One gotcha is what happens in is prime. Why it takes almost more than 5 seconds. And if you profile, you can see that some functions have yellow warning rectangles, or not rectangles, triangles. So if I hover over this yellow rectangle, oh, triangle, sorry, it's not zoomed in, but it says not optimized try-catch statement. If I actually click and go to this function, Chrome warns me that because I used try-catch inside this function, the try-catch block prevents the V8 engine from actually optimizing this JavaScript any more than just the text to execute. Our functions are optimized. Try-catch automatically stops V8 from even trying to optimize this any further. It's like Java just-in-time compiler versus non-optimized code. So is this like scripting in Chrome DevTools and automating? It's not really automating anything. The code snippets only allow me to run arbitrary pieces of code in the context of a page without adding it to my page that I have to load. So once I profile, this is the top bottleneck. It even tells me that there is try-catch statement. I can easily switch and try removing try-catch. And let me reload the page. I just checked out step number 1. And all I've done here is I removed the try-catch block. That's it. So I used to have it. I removed it. And let's see how fast it runs now. So I'll go back to 1000. I'll go to profile scope method. OK, I wrapped it. Find. OK, I'll go back to profiles. And because I use the same name, it actually saves it under the same tab. Now, this is a little bit weird. It actually did not change anything, but it stopped showing it. Let me reload the page again and try it again. Sometimes DevTools does not do what I expect it to do. So I'm going to wrap the method. I'm going to click Find again. Very weird. It actually takes the same time, even though this is it should be much faster. Let me see if I'm doing something incorrectly. Profiles, source snippets, find. Oh, now it's gone. So sometimes the Chrome DevTools doesn't actually refresh the source that it has inside, and that's what was causing the problem here. I expect it to show a much faster execution. In this case, the execution takes only 3 seconds as opposed to 9. How does the try-catch affect performance? V8 does 2 levels of code execution. First, it just compiles JavaScript to code bytes. Second, it tries to optimize functions that are very simple, like that they use the same types of arguments. Automatically, it does not optimize anything that has try-catch. It just can't. And in this case, let's look at what changed, right? So it used to be that is prime took almost 5 seconds. And now look at this. Total. All the 1,000 or number of calls to is prime only took 12 milliseconds. We just removed our tab bottleneck, and it cut the time from running this function just by removing try catch from 5 seconds to 12 milliseconds. This is a huge difference. It's order of a couple thousand. And the difference between optimized and non-optimized code is tremendous. Luckily, the Chrome DevTools actually warns you about things that it cannot optimize. The scope apply cannot be optimized, but it only spends like less than 2 milliseconds there. So this is a very typical pattern that I found in my applications. Is I assume that AngularJS is slow, but in reality, the tab bottleneck is usually not AngularJS code. It's usually my code. And I think what we have to profile is usually our application, and what we will find is our code is the initial bottleneck. So now that we can find this much, much faster, let me switch back to this and figure out what else I want to show, because I have only maybe 10, 15 minutes. I can actually find a lot more primes, right? It's much faster. I can find 10,000 primes. And soon it will finish, hopefully. Right now, the browser is frozen, right? Because it's searching. And what I'll show next is optimizing the digest cycle. I think, I forgot. I have to switch to the next step 2. What's bad about Chrome is that if you have a long-running application and you try to kill it, it doesn't actually kill. Okay, let me open it again. Okay. Let's try 10,000. Okay, so we found 10,000 primes. We can even find 100,000, and it should be fine. And what I will show next is that once we created this ginormous table, right, of results, our application will become very, very sluggish. And it will be sluggish because when it finishes, maybe 100,000 is a little bit. $10,000. Still not done. So let's say that we have all these results, right? If we look at our code, this is how I show the results. I have a table, and I have ng repeat, which is very, very common. I do prime in primes. Primes is just an array. And then each cell uses double binding. Okay? So if we actually had a lot of primes here, and we were trying to change something here, we would see a noticeable delay. Every time there is a change in any value in a model, the digest cycle runs, and it has to go and reevaluate every watcher on a page, right? It has to see if anything changed, if number of primes change, or the order changed, or if the value of this expression after running through lowercase changed. And if it changed, then it has to update the DOM. Otherwise, it doesn't have to update the DOM. But it has to run through every watcher. So for each prime, I have a row in a table with 5 elements. So that means if I have, let's say, 10,000 primes, then I have 50,000 watchers. And we can go and see how many watchers there are on a page. Again, I have a little snippet. All it does goes through the DOM and finds watchers. So in this case, I have 30,000. So I guess I optimize some of this. Which version of Angular am I running? Okay. If I were running Angular 1.2, then I would have all 50,000. Angular 1.3 and 1.4 notices that this is a constant and actually optimizes this by default, so I don't have to worry about it. If you're still running Angular 1.2, this would be a watcher, so your page would be even slower. What you have to optimize at this point is, or measure at least, is the idle digest cycle. So I have a little snippet, and all it does is finds the root scope and it kicks off apply. So that means no data has changed. All it does is says run the digest cycle. Let's see how long it takes. So I can execute this, and in this case, it's 14 milliseconds, which is not bad, right? Our goal is to have everything under 60 milliseconds. That allows the page to refresh at 60 frames per second. 14 is not that is not a lot, but it's not that small either. What we can do at this case is get this number and then look back at our markup and see which expressions are not necessary. Well, this probably was optimized by default because it's an easy case. But look at this expression for the second cell. Let me even zoom in a little bit. So I have actual index number. I'm adding 1, then I'm converting it to number, and I'm even passing a 0 argument. And then I'm converting it to uppercase. The value of this will be the number itself. So these two filters have no effect on the output, right? So I can safely remove this, and nothing on a page will change. The same with the number itself. I'm converting this again to the number and then uppercase, but the result will be the number again. And the last thing is this flag that you see as the last column. Is it prime? Well, yes, because that's how I found it. So the result of this will always be true. So I think the next step that I've done was remove all these unnecessary expressions, all the unnecessary filters. So let me see if I can show this. So step 4. Okay, let's refresh this. Nope, not yet. Step 3 maybe. Okay. Okay, so notice here that I removed everything but the actual number formatting. I can try the same 10,000. Okay, it's done. And if I go back and measure how long a digest cycle runs, 18 milliseconds. Something is very weird today. Huh. Very, very, very weird. Why is it 18 milliseconds if I remove stuff? I apologize. I guess Angular 1.4 behaves a little bit different from 1.2 when I actually went through these examples last time. Huh. Well, let's move on. So we have 10,000 primes, and I think I'll speak for a couple more minutes before I actually open the floor for questions. Notice that we actually show generating 10,000 primes, but we can only show a couple at a time, right? So why do we spend a couple seconds generating all this data if we cannot even show it? So one of the things that I was doing was switch how I generate primes. And the interesting thing is this working in batches, and especially working offloading computation to a web worker. So whenever you have a performance problem, you have to think about the total cycle. Generating data, putting it on the screen, and then letting the browser repaint. So let me switch to maybe the next one. And okay, HTTP server. So if I open step 11 at this point, then localhost. So this is an interesting implementation. Instead of me doing everything in the main loop and kind of competing with a browser, I load a web worker, and it's really easy to do inside Angular. And when I actually find the primes in a web worker, and I let the main browser do its job. So let's see if it is noticeably faster. Notice that it generates and refreshes the page in parallel. Again, let me refresh this. And at this point, I will draw the timeline. So we looked at the CPU profiling. Let's look at the overall picture. The Chrome DevTools actually updated the timeline profile a lot. This will show everything that's going on, from CPU to browser layout to repaint. So what we want to see is everything under this 60 frames per second. That's our target. We want to be able to generate and paint the new numbers under 60 frames per second. I'm not sure if we can reach it, but let's try. So I'm going to start this, and I'm going to click Find. I can scroll, because this is not frozen at all. It will take a couple seconds to actually show the timeline. But after it's done, we'll see a very interesting chart. Okay. So this shows both scripting, the orange. Purple is layout, and then gray is browser processing. So majority of individual batches came under 30 frames per second. Not as good as I wanted, but still acceptable. You can switch to different views and analyze how the browser actually generates the numbers. And what you really want to see is something like this, right? Very thin spikes. And if you focus on one, you can see that this particular sequence of batches took only 2.5 milliseconds. So that means that my web worker generated primes, and when I drew everything in just a couple of milliseconds, which is what we wanted to do. And then the browser took a little bit longer to actually recalculate the layout and show it on the screen. So use this tool to figure out if there is anything weird going on, like the layout is taking too long, or anything that's way above 30 frames per second, way slower than 30 frames per second. And finally, I just want to show the last thing is, if we scroll or if we update something here, one of the numbers, we'll have to redraw the whole page because it has everything together in a single table. Obviously, this is not the best solution. So let me show an example where, excellent. Instead of generating everything, as you can see on the top, I only generated 100 prime numbers. As I scroll, I see more numbers. And if you look down at the bottom, I'm computing numbers on demand. So this is another performance thing that you might consider in your application. Maybe you don't generate all the numbers, but as the user scrolls, maybe you generate more numbers. This actually has a very good profile. Again, if I start profiling and I start scrolling, see, the numbers appear fine. And if I stop, then it will show very nice graph. So for example, this couple of bars, it's just me scrolling. Once I reach bottom of the screen and I need more numbers, I actually generate, put them on the screen, and then I can scroll again without having any interference, any more computation. So if your application allows this use case, generating data on demand, I encourage you to use it. So I think I spent 36 minutes kind of showing what I've done. I just want to encourage you to look at a blog post. It describes all the code samples in detail. There are a whole bunch of other steps, including memory profiling and pre-allocating memory. I encourage you to look at code snippets because it has a lot of Angular performance, like counting number of watchers, idle digest cycle, and things like that. I also encourage you to look at this video from ngconf, because this guy talks about minimizing number of watchers, and especially minimizing the number of watchers that you don't even know what you have. So at this point, I would like to answer maybe a couple of questions, if that's okay with you guys.
Awesome.
Yeah.
Yeah, thanks, Gleb. That was really great. So I'll, yeah, everyone who's in the session, please feel free to throw any questions into chat. I can kick things off with some that we were emailed in. Some of these are pretty specific to making the decision to use Angular as opposed to another JavaScript framework. So I'm not sure how familiar you are with other ones, but maybe you can address these. So someone wrote in, I tend to write code that is very math and processor intensive. It seems like Angular would be a perfect fit for the user interaction aspect of my site, and I get how it'll speed up responsiveness to user actions. However, I'm not sure that Angular would be beneficial when it comes to organizing significant data in the browser memory. It seems like I would just be adding an extra layer of abstraction. Given that information, can you make any suggestions for him?
So for computing, I would suggest looking at web workers. Just like I showed, they're perfect for computing stuff very quickly and in a separate thread. You can have probably as many separate threads as separate web workers as you need. They are supported on 90% of the modern browsers, including mobile browsers. The only one who doesn't really support them is like IE 8 and 9, I think. The newer IEs support them out of the box with one small limitation. So if you really need high performance and you don't want to block your application, you should look at web workers. As far as memory organization, you should look at native buffer arrays for organizing your memory. So one thing I have not shown here, but you can profile your memory allocation. It's not really Angular. Angular doesn't really help you with that. What helps is good computer science. And in this case, if you know the number of items that you will generate, like the number of primes, do not allocate array dynamically by just pushing element one by one, right? Instead, generate new array in a single operation and then add each generated item one by one at a given index. This will be a lot more performant for memory allocation because By default, JavaScript, if it doesn't know the final size of array, will allocate, let's say, 100 elements. As you reach 100, it will allocate an array of 200 and garbage collect the previous one. So you will hit those garbage collection points because it has to allocate like double the size of array at each point. So if you know the total number of items, pre-allocate all your arrays. Angular doesn't really solve this problem for you.
Gotcha. Yeah, that's helpful. Someone else was wondering, I've done some reading that Backbone and maybe other frameworks are smaller, more
Yes.
lightweight. Would I be better off using one of these smaller frameworks? Obviously, it depends on what their project is, but do you have any thoughts there?
Yes. So according to latest stats, right, 85% of website payload, right, how long, or the total amount of bytes that you need to actually show up on a major website is not JavaScript, it's not CSS, it's images, right? All your background, all your thumbnails and stuff like that. By saving, I think Backbone is like 30K, Angular 1.2 is 100K, right? An average size right now is more than a megabyte. You're going to save 70 kilobytes, but you will not have all the stuff that Angular gives you, right? So if you think that this is a valid optimization, I personally disagree. I think the total size of JavaScript is very, very small and inefficient optimization. Most of the times, if you use CDN, right, for your libraries like Backbone and Angular, there is a very high chance that the user already has it preloaded in the browser, right? So saving 70 kilobytes but going to Backbone is not really a very major optimization.
Makes sense. I've seen discussions of Angular 2.0. Should I go through the effort of implementing Angular or wait to go the 2.0 route?
So I just came back from NGConf, where I was listening to Angular 2 talks. Angular 2 is an interesting project. It's really almost like a separate or new framework as opposed to Angular 1, but it requires different tools, different thinking, probably simpler thinking, takes full advantage of ES6 features, and is implemented in TypeScript. It's a big, big change. If you're thinking about doing something today, Angular 2 will come out at least in 2016, right? Not even this year. The Angular team also pledged supporting Angular 1, X, for at least 2 more years. So I would strongly suggest that if you need to design a web app today, start with Angular 1. Don't even worry about Angular 2. When the time comes, you'll be able to do a mental switch. It will be actually simpler. For now, take full advantage of Angular 1.x, wherever. Another interesting thing is a lot of components like router, digest cycle, I think, will be re-implemented. They actually will be part of Angular 1.5 or even Angular 1.4. So the things that you'll start using with Angular 1.4 will be part of Angular 2. So it's not like it will be complete change. We try to modularize things. So I would suggest start with Angular. You have plenty of time to use it and be supported, and you will actually use a lot of components that will be part of Angular 2 no matter what happens.
Awesome. So, assuming you're comfortable in multiple forms of JavaScript, what are the variables to you that would make you choose to start a project going down the road committed to Angular versus any of the other options?
I think the main one that I find Angular to be a really good one is, do I have any novice JavaScript developers or designers? Do I start with maybe a static HTML, markup, right? Maybe like a prototype. If that's the case, I would go with Angular, because Angular makes it very, very simple to build a static HTML prototype and then add live features like data, two-way binding that anyone can do. It's literally very, very simple to take to-do list and then make it live, connected to backend without using anything extra. There is a difference between Angular versus React. People right now always say that, oh, we're abandoning Angular for React. React is a very different beast. Unless you're really good with using functional JavaScript, you should not use React. And none of the designers who know how to create static HTML prototypes will be able to improve those or make those live by using React. It has to be completely re-engineered from scratch. So if you start with a static prototype, go with Angular. If you're starting from scratch and you feel better at JavaScript than HTML or CSS, maybe consider React or Backbone.
Cool. What have been your favorite resources for learning Angular and just getting comfortable?
So there is a NG book, which is excellent. I highly recommend buying that book. It's an ebook, and just going there through the book, lesson by lesson, every week at your own pace. It's unbelievable. Gives you all the detail you need. Another good resource is this. So this is a giant collection of Angular resources, including tutorials, videos, books, blog posts, anything that has to do with Angular. There's probably a good link for that, including Angular 2, testing, comparison to other frameworks, I think. So use those two resources as a starting points.
Awesome. Well, if anyone else has any other questions, please feel to jump in. I sort of covered a lot of the ones that were emailed in. But Gleb, other than your blog, where should people check out your work? Should they? Are you on Twitter?
Yes. Let me actually switch maybe encode share and show a couple slides.
Oh, okay, great.
Just to finish presentation. Let me see, screen share, and I guess this one. So we looked at primes. So these are some of the steps that you can do by going through a blog post and playing with the code. You can separate it from removing your own V8 specific, JavaScript specific, to kind of profile Angular stuff and optimizing HTML, right? That's the purple. And then finally, advanced techniques are yellow. These are some of the steps again. And let me just go to a couple of performance lessons, and just to finish with. What most important is to be able to accurately profile code. If you cannot profile your actual live application, then it's hard to remove what is truly the bottleneck. You always optimize the top bottleneck, because if you optimize something else, it might not necessarily matter. And if you optimize the top bottleneck, it might affect the order of everything below it. Just a rule of thumb, use as few watchers as possible on your page, because every watcher runs on every digest cycle. That means everything is expensive. The easiest thing, use fewer filters, maybe pre-compute data. If you can, split large chunks of work into batches. And finally, maybe you can do things on demand, like when the user scrolls and needs to see more data, maybe then do work. And another thing, there is Angular versus Repeat. It's an excellent plugin that allows you to only keep visible portions in the DOM. It's excellent. Go check it out. This will speed up your pages, especially if they have lots of rows in the tables. And just to finish, so I have a question. Could you share some resources to script? But I'll share my code snippets again. So go to this repo, there are articles, and I show how to use those resources. And finally, just to kind of conclude, there is always a discussion, is Angular faster or React is faster? It's like comparing oranges to apples. I think that Angular is not inherently slow. It allows you to do very interesting things and tries to optimize it for you. But unless you actually know what's going on, it might become slow. Inherently, it's not that slow. And the cool thing is that you can actually optimize each part step by step, but still use Angular. Like, you don't have to go to some other tools and bring any third-party library to actually make Angular application fast. You just have to know things, how they work, how a browser works, how a single event loop works, and then you'll be able to optimize things. And just to go back to, you can follow me on Twitter. I post a bunch of my updates. I have tools for Angular and testing Angular. And then the last thing is that on my blog, I even have a bunch of articles tagged with performance tag. Let me see if I can. Well, probably don't want to do that, but let's see if I can. No, I cannot tag. So I'm going to switch here, and on my blog, if you go to performance, I'm showing examples of optimizing performance using code snippets, even looking at raw V8 in Node and kind of trying to determine if a function can be optimized or not. But the best way to actually stay in touch is by probably following me on Twitter at my last name.
Awesome.
Debugging Angular app. So I use a tool called ng Inspector, and also I use a tool called Veteran. They're both, I would say, alpha quality. They both kind of interfered with my work, so I don't use them anymore. I probably use code snippets more to debug things, and I strongly suggest that you have a good unit test. Angular is an excellent framework if you want your code to be tested. So I suggest you look at unit testing, and especially because Angular is kind of, how should I say this? Kind of verbose. You should look at this project that Kensho released. It's called Kensho ng-describe. It's kind of like a describe for Jasmine or Mocha. So basically, instead of, let me zoom in, instead of writing the unit test and writing lots of code just to set up things, you can just say inject or take this module, inject this particular thing, test it. So it removes all the boilerplate code from your unit test, and that allows you to test things easily. Angular sometimes could be tricky to learn, and especially by unit testing. I think ng-describe kind of removes a lot of those blockers. Any other questions, guys? It's hard to talk and not being able to see people. Like, usually in a live presentation, people kind of nod or ask questions. It's a little bit flying blind.
I understand. No, but I think everyone really got a lot out of this one. And for everyone tuning in, if you feel like you need another pass at looking at all the slides Gleb showed, this will be on the Code Mentor YouTube channel as soon as we wrap up. I definitely recommend taking another couple passes to really digest it all. But wow, Gleb, thank you so much for your time. And if anyone has any Angular projects you're working on, need any assistance, obviously Code Mentor is available to you. And you can check out more office hours coming up. We have a lot of them coming up in the next few weeks. A couple more about Angular as well too. So we'll be focused on this for a little bit. But with that, if there's nothing else, I'll say good afternoon, or again, good morning or evening, wherever you are. And thank you so much.
Thank you, Mark. And I know just from talking to people at NG conference, to other presenters, they actually have Code Mentors office hours as well. So you have a good group of people.
Awesome. Yeah, we've been NJConf has definitely sent some great people our way. So thanks.
Excellent.
Awesome. All right. Well, good afternoon, everybody.